So this video to discuss the one numerical measure that I didn't discuss last time, which is called the coefficient of variation, also called CV. Now the coefficient of variation, that is a ratio of standard deviation S and the mean. We denote the mean by y bar. So this is the ratio times 100%. So this is the ratio of SD divided by the mean times 100. Now the question is why we want to use that. To understand that, we need to understand a little bit about the standard deviation. A standard deviation, that is the measure that if this is the mean at the middle, how far we go on this two direction to measure the variation, how much it vary from the mean on both sides. So this is the measure. So this is one standard deviation distance from mean, and the other direction another standard deviation distance. So this is pretty much a measure of how much it vary around mean. But it could be of different units. If it's of different units, we need to make a measure which is unit free. And this is exactly the coefficient of variation is a measurement. So CV, because it's unit free, can compare standard deviation from different experiments. In your book, they discussed an example that if we want to compare the variation of weight between an elephant and a mouse, the S will be incredibly small for mouse, the variation. S will be incredibly huge for elephant. But if I divide that by the mean, then it's a percentage that I can compare how much increase in percentage happens for the mouse weight and how much increase in percentage happens for the elephant's weight. So that's the purpose. If you want to read that, that's in your page 64 in your book. But that's an important measure. Again, we will use Minitab to calculate this, so you don't need to know how to calculate that by hand. That's true for this one too. On the same note, we need to discuss one more thing about the box plot. So the box plot, if you remember that this is the box plot, this is the end of the whiskers, and this is the mid value Q2, we actually can find out the shape of the box plot. How do I find the shape? Calculating the distance from the median to this end. So here, if I draw this, you can see that the median is in the middle, but it's not quite in the middle. This side is dragging on. So if I do this direction, you can see that this is kind of this dragging on the right side. So this is right skewed. And similarly, depending on the position of the median with respect to the whiskers, which end is longer, we can conclude about the shape of the distribution. Now there is one difference here. In your book, they are considering outliers meaning that if I have outlier here, two of these outliers here, they're going to drag this to this direction. But that's not right. So we will not consider outliers for determining the shape of the distribution. So that's important. That will be a little difference with the book. The book is considering the outliers we think is wrong. So we will not consider the outliers. We will stop right here. We will not consider this part when we are considering whether it's symmetric or right skewed or left skewed. So that's one little thing that is different from the book. It'll help you during the homework. But if you check the answers at the back of the book for the shape part of the homework, it will be different at the back of the book because they are considering the outliers and we are not. So I want to just make it clear with these two things that I missed. I didn't discuss in the first numerical measure video. So name of this will be coefficient of variation video. You need to watch that too. And all this I'm going to discuss in terms of Minitab in the Minitab instructional video. All right.